So the equations for proportional relationships always take this form: y equals kx. All right. Eventually this k, by the way, is going to turn into an m. It won't be k anymore. K, by the way, is just, it's the unit rate where x is 1. So if we can remember that in the tables and in the graphs, then we should be able to figure those out pretty good. All right. So we're just looking for where x is 1. That is the k value, the y is. So for each of the following tables, x and y are in proportional relationships. Write an equation for y in terms of x. So what that means is that all of these should be written in this form: y equals some coefficient times the x. We just got to figure out what the coefficient is, okay? So on A, for A, right here, well, in this one, we look, again, the x right here is 1, and then the y value is the coefficient, therefore. I'm just going to replace the coefficient with 4. That is all. So on B, this one does not show where x is 1, so we got to figure that out. So just kind of extend this table, make a 1 right account. Now remember, it's proportional, right? So we can make this equivalent, and I'm going to do y's over x's, just because for now. It'll be very useful later, by the way. So I got to find two values to use, and right there we can see on this one that x is 1, but we don't know the y value, right? That's what we got to figure out. So we got three values that we could use. We got 48, 35.7, and 36. Which of these three values do you guys want to use? 48. All right. So the x is 40 in this case. So my x's are in the denominator. My y's are in the numerator. So there's the 8. And then we just got to figure out what that y is. All right, from right account. So from 40, to get 40 to be a 1, what would we do to that 40? Divided by 40. That's the nice thing about this unit rate. 40 divided by 40 is 1, so 88 divided by 40 is, why make it a fraction? 1/5 or 0.2, right? So we can use the decimal, 0.2. So what's the equation? It should be y equals some value, the coefficient, times the x, right? What value goes there to the coefficient? Yeah, 0.2. Because that's where the x is 1. Now, of course, if you wanted to, you could write this as y equals, as a fraction, it'd be 1/5 times the x as well. Either one of these. All right, you guys take a moment and write the equation for C. So what is the coefficient for the x? 1/3, right? That's very good. How do we know it's 1/3? Because this is where x is 1. Bam, there's the y value as the coefficient. All right, take a moment, 10 seconds. Write the equation for E. All right, what coefficient did you guys get? Now this one would be positive 2, because we need the x to be a positive 1 right here. The y value is 2, just drop it in there. Bam. So that was pretty convenient because it gave us where x is 1, right? But again, we should be able to do that even if it doesn't give us where x is 1. All right, so on H here, again, it does not give us where x is 1. So we'll have to figure that out on our own. So again, I always put my fractions as the y's over the x's. I've got two equal ratio fractions. And which of the two values do you guys want to use? 90, 54, 10, 6. 10, 6. So let's use this one, where my y is 6 and my x is 10. And specifically, we want right here the x to be a 1. So to make a 10 a 1, we divide it by itself, 10. And we'd do 6 divided by 10, which is 0.6. Or if you want the fraction, 3/5. So that gives us 1 and 3/5, or 0.6. So the equation is a y equals, what's the coefficient of x? 3/5, or yeah, you could write y equals 0.6x. Either one of these two will work. When writing an equation with the table, here's all we got to do for this, okay? Now sometimes it won't always be quite like this where it shows specifically what to do, but for all of these, we're going to write this as y equals, and then we got the coefficient of x, which just goes in front of the x right here, okay? So what number goes in front? Well, for the x, we got to look and find where x is 1. Well, that's not 1 right there, but this is 1. The y value when x is 1 is the coefficient of x, so it's 6. Bam, that's our equation. It is done. All right, f. So again, we should have y equals some coefficient with x. We just got to figure out what that coefficient is. So again, we're going to look and see in the table if we can find where x is 1. That's not 1. This is a negative 1, but it's negative. We just want a positive 1.
But there's only a negative.
There we go. We'll look. So where x is 1, we find the y value. It is the coefficient of x. Done. That is the unit rate that we want. We want the x to be 1 on of these. So on I, this is y equals, again, we got a coefficient of x. What's the coefficient of x? Just looking at that table.
Well,
Yeah?
negative 1/2.
-1/2. Very good. How do we know? Because this is where x is 1. So the y value is the coefficient. He will try to trick us, which is okay. But don't be tricked, okay? So on at these, we got y equals the coefficient of x with x. And we can set up a proportion. Again, I always do y's over x's. So I can use one of these. And by the way, again, the reason we need to use a proportion on this is because in this table, it doesn't show us where x is 1. It showed us where y is 1, but that isn't going to help us on this, okay? I guess it could, just not directly. So we got to choose one of these values to use. Do you guys want to use 0.751 or 3.75 and 5? All right, so we'll use this ordered pair right here. Now the y's, which are in the numerator, right? I got a y value that's 1 and an x value that's 0.75. Now I want my x, though, to be a 1. That's what I really want, my x to be 1. So how do I make a 0.75 a 1? Now remember, with ratios and proportions, we can't add or subtract. So the best way to make something 1 is to divide it by itself. So if I divide 0.75 by 0.75, I get 1, which is what we want. But I've got to take 1 and divide that by 0.75, which would be, as a fraction, it would be 4/3, or 1.3 repeating. So that would be my coefficient. I'm just going to write the fraction because it looks a lot prettier than bar notation. The variables x and y are related. Write an equation for y in terms of x. So again, that's just the same thing we've been doing. It'll be y equals some coefficient of x times x. Write the ordered pair that corresponds to the unit rate, 1r. And then write one more ordered pair that is proportional. We'll write a couple actually for each of these. So it's good to know these are proportional, because what that means is that the unit rate that we want is for this to be 1 something, right? So if I have 2, 8, what ordered pair would be 1? And what would the y value be on that? Yeah? 4. How do you get that? There you go, right? Because as the ratios go, we'd have 8 over 2. Again, this is y over x. Should equal something over 1. And yes, we would divide this by 2 to get 1. So 8 divided by 2 is 4. So we got 4, 1, which means that the coefficient of x is 4. Then, if that's the case, what other ordered pairs would work on these? 312 would work. One more. 624. All right, let's try one more. Let's make this a -3. -12. Nailed it. Very good. Now hopefully we can see, since we were choosing the x value, I just did 4 times the -3 to get -12 in the equation right there. So on C, once again, we should have an equation y equals some coefficient with x. What is the coefficient of x? Well, what's the unit rate ordered pair? Again, that's where the x is 1. What's the y value when x is 1? That was given right there, so it's -20. And I can put that as the coefficient of x as well. Bam. So what we need now are extra ordered pairs. What are some that you guys got? 2, -40. That's a good one. One more?
60.
Yeah, very good. You guys see the pattern right there? What if we made this a -5 for the x? What would the y value be? Well, again, I go back to the equation. Yeah. I do -20 times -5, which is a positive 100. So yeah, if I go back to the equation, which we had already, right? I got y equals -20 times the x. But I'm saying in this ordered pair that x was -5, right? So I go back here and I replace that x with -5. And I can put this in my calculator, -20 times -5, which is a positive 100. There it is. Now the y value is 100. All right, on H, again, we should find the unit rate ordered pair first because we just want the x to be 1, right? Well, do we know what the y value is when x is 1? Yeah, it gave it to us in this ordered pair, -2/5. So that makes this pretty easy to write the equation. Y equals, well, -2/5 times whatever x value we have. So when we want to find other ordered pairs, right, let's say that we chose maybe like 10 for the x. Well, then I can come back up here, and I don't necessarily need to use the equation because I can always compare my y's and x's as fractions. So over here I got -2/5 over 1. And this should equal where x is 10, right? So how do we make a 1 a 10? You can multiply it by 10 to get 10. Then you got -2/5 times 10, which is -4. So that gives us a -4 right here. So that's just another way you can do it. Of course, you can put any value of x into the equation if you want, and that may be easier for you. But you got to choose. You got to choose which way you like the best. All right, you guys take a moment and try I. All right. So the unit rate ordered pair, what'd you guys get? 1, 2, 1. Should have got 2 right there, right?
Yeah.
All Now, how do we get that? Well, once again, we could make this 180 over 90. So again, we're looking at y's over x's. And up in count, we don't know the y value, but we see the x is 1. So 90 divided by 90, that should be 90, is 1. So 80 divided by 90 is 2. So that's where we get this 2, which means in the equation we got y equals that y value, which is 2 times the x. So what were some other additional ordered pairs that you guys got? Yeah. 2, 4 is good. Yeah. Yeah.
180 to 360.
180. That's correct. Very nice. Did anyone use any negatives for the x? Let me ask you this then. What if x was negative 3? What would the y value be? Negative 6. Very good. All right, take a moment and try J as well. All right, what equation did you guys get? Y equals 0.8 x, right? So with that, what would the unit rate ordered pair be? 1 and 0.8. So yeah, how did we get that? Let's look. Okay. So again, I'm doing y's over x's, like this, right? And this ordered pair gave us 48 as the y and 60 as the x. And the unit rate ordered pair, we always want the x to be a 1. So it's my denominator. So how did I get 60 to be 1? I divided it by 60. And then I got to do the same thing to the 48 though, divided by 60. And I get 0.8, or some of you guys like the fraction 4/5. So yeah. So that means your unit rate ordered pair could have used the fraction as well. Either way is good. So an additional ordered pair, what did you guys get? Yeah?
-6 to -24 over 5.
Yes, that's very good. Anyone else? Good use of the negatives right there. What if we had 3? And maybe something like 2.4, right? 0.8 times 3. Just using the equation right there. So here we have the point 15.3. We need the equation, but we need the unit rated as an ordered pair. Now we've already seen with the tables that the unit rate has to be, the x value has to be a 1, whatever it is, okay? So on this one, again, I can set up my proportion with y's over x's. And up in count, we've got 3 as the y and 15 as the x. But we want an equivalent fraction where x is 1. So how do we do these? Well, yeah?
You divide 3 by 3.
It's close. That's close. So in the denominator, right, I got to take 15 and turn it into a 1.
Oh, you divide 15 by 15.
There you go.
No, you divide 3 by 15. That's after. It's after.
Yeah, very good, yep. So 15 divided by 15 is 1. So 3 divided by 15 is 0.2, or some of you guys like the 1/5. Either way. So as the ordered pair, we could go back and write that, either the decimal, 0.2, or the fraction, 1/5. And then the equation is a little bit easier for us. Y equals, what's the coefficient of x? It's at 0.2. See? Because the x is the 1, and its corresponding y value is the coefficient of x. So what are some additional ordered pairs onto these that would be proportional? Well, I don't know. Let's say like 5. If x was 5, then what would the y be? 1.
1.
What if x was negative 10? What would the y be?
2. No.
Yeah, that one's going to be negative 2. Now, how'd you get negative 2? Yeah?
Never mind. I don't know how to explain it.
All right, so I'm just using the equation on this. I got 0.2 times the x, which was negative 10, and I get negative 2. Yeah, it's kind of like moving the decimal over. So on these, we need another ordered pair, the unit rate ordered pair. Again, the x is 1. Now, if x is 1, what is the y value?
25.
Yeah,
25.
it's close. I remember right here at the top it says x is
1.
2
1.
and the y is 25. We want to make the x 1.
Oh, yeah. Divided by 2.
Yeah, divided by 2. And that would be
12.5.
12.5. So what's the equation then? Someone tell us? Yeah?
Oh wait, no, no.
So it should always be y equals what?
12.5x.
There you go, excellent. 12.5x. So let's look at some other additional ordered pairs on these. So what would be another one, you guys?
220. Never mind.
350.
Now 2 to 25, we have that one.
3 to 50.
4 to 50, very good.
Oh, shoot.
And then what's another one?
8
to 100.
8 to 100 works. Let's try one more. Let me give you the x value though.
16 to 8.
Let's-
8,000 to 5,000.
Well, hold on. Let's close.
50,000.
Let's try negative 12. What if x was negative 12? What would the y value be?
Negative 150.
That's correct. Negative
100.
I got negative, 150. What the heck? Negative 150. Excellent work. All right, so we need the unit rate ordered pair. So again, this would be 1 and something. Well, up in here, so we got y's over x's, starting with 2 over 3, but we want this to be, the x to be 1. So what would its corresponding y value be? So we take the 3 and divide it by 3 to get 1. 2 divided by 3, I'm just going to make it a fraction, 2/3. Or 0.6 repeating, but the fraction would still look a lot better to me. So the equation is y equals
2/3
2/3
x.
x. Very nice. So what are some additional ordered pairs? Now if you wanted to, go ahead.
2 and 4 6.
It's close. It would be 2 and then 4/3.
4/3. Oh yeah.
Yeah, because we're just doubling the numerator. Now what you can do is we can come back to this original and double those values, so that'd be 6/4. Or you could negative them. Negative 3, negative 2. Take the opposite. It's still proportional. All of these are additional ordered pairs that still are proportional. So on this one we got 2 and 2/3. So if we wanted it to be 1 for that unit rate ordered pair, what would the corresponding y value be? Well, the 2 we would have to divide by 2 to get 1, right? So we'd take 2/3 divided by 2, and that would give us 1/3. So the equation is y equals that y value, 1/3, times the x. Very good. And then what are some additional ordered pairs that we could use?
2 and 2/3.
Now we have that one already, right?
Oh yeah. Okay.
That's very good. 3 to 1 or 3/3, right? What if we had 6 then? 2. What if we had 9er? 3. There we go. Those are all good. We don't really need to use ones with fractions, but you can. Choice is yours. All right, what about G? Now here's what we want to start out with is we'll say the unit rate is 0.25 to 1. But what's wrong with this? Yeah, very good. See, the 0.25 is in the x value, which is where the 1 needs to be. So yeah, that's not going to work for us. So we'll get rid of this garbage. So what is it if x is 1? Yeah?
You multiply by 4.
Very good. So the ordered pair is 1.
And then it would be 4.
4, very good. So the equation is y equals
4x.
4x, very nice. So what are some other ordered pairs that work on this?
2, 8.
2, 8.
3,
Another one?
16.
3, that's close, 12, right?
3, 12.
3, 12. What if it was negative 4?
Negative 16.
Negative 16, very nice. Use the equation given to complete the table, and y equals 3x. So, up in here, this first one we see x is 6, so y equals 3 times the x, which is 6. 3 times 6 is 18, so y is 18. Now this next one though is very different because it gives us the y value, so y is, let's write the equation first. So we got y equals 3 times the x, but it shows y is 24, right? So I'm going to replace y with 24. Now this is an equation, which I think was unit 3 for us, which means that we're just going to solve this like we would a regular equation. How would we solve this? Well, we should divide both sides by 3, right? That gives us 1x equals 8. Bam. There's our table. So y equals 5 halves x. So again, we're going to use this equation to solve these. So x is 10, right? So y equals 5 halves times the x. But this first row shows that x is 10. So I will replace x with 10. And what do I get? Should be 25. Now this next one's very different because it gives us the y value again. So it's 5 halves equals 5 halves times x. So to solve this, I would divide both sides by 5 halves. Not everyone would need to do this, but that gives us 1 right there. 1x equals 1. Bam. And then the final one, where x is 5. So y equals 5 halves times the x, which in this case is 5. So I'd get 25 halves. Or, some of you guys like the decimal, 12.5. So on E, where x is 1, so y equals 3/4 times 1, which is 3/4. And then the next one, y equals 3/4 times 16. And I would just plug that into a calculator, and I should get 12. But the next one gives us the y value, so 9 equals 3/4 times the x. So dividing both sides by 3/4 gives us 1x. 9 divided by the 3/4 should give us 12. So there's our 12. Take a moment, try G, and then we'll just show you the answers. If you have questions, then we'll answer them. All right, here we go. Excellent work on those. So on B, right up in here, see x is 20, so the equation is y equals 1/2 times x. But it's telling us right here that x is 20. So I'm going to replace x with 20, and I got 1/2 times 20, which is 10. Now this next one, okay, we're using the same equation, y equals 1/2 x. But here, y is 16, so I'm replacing the y with 16. So half of something is 16. So what would we do to solve this one?
Multiply it by 2.
You can multiply them by 2, that's very good. So multiply both sides by 2. So that cancels these out, and I got 1x equals 32. So this 32 goes right here. All right, what if we put 9 in for x? What would you get?
I'm gonna get
Wait, would it? It's fine.
Yeah, this would work. Either one of these. Y equals negative 4x. So y equals negative 4x. But this first row, the x is negative 2. So negative 4 times negative 2. Yeah, that one's going to be positive 8. Very good. Now this next one, though,
negative 8.
yeah, y equals negative 4 times a positive 2, which is negative 8. Very good. Well, if y is 1, what is x?
Wait, 5.
It's close, close. So we get 1 equals negative 4 times x. And to solve this, we'll divide both sides by negative 4, so that we get 1x equals, I'll just make it negative 1/4. Better than you'd show that stuff. But that's our answer. Some of you guys like the decimal though, 0.25. Take a moment and try F, and then we'll show your answers, and then we'll see if you guys have any questions.
Can you write it 1 over
There we go.
10?
On this one?
Yeah.
No, because, and here's y, right? So the equation is y equals 10x. But right there it shows that y is 10. So 10 times what is 10? Or we can just divide both sides by 10. So 1x, the x value is 1. So that's how we got this one right there. Do h, what do you think, 30 seconds? All right, we got to be careful on this one. If x is 0, y is negative 0?
0.
Just 0. 0 is neither negative or positive.
Actually, it would be either negative 0 to 0.
No, it's just 0.
It should be either 0. Because you have to
What about when x is 4?
not 0. Negative.
Negative 4, very good. What about when x is negative 4? Yeah, because it's negative 4, which is 4. There we go. For each of the following graphs, write an equation for y in terms of x. So again, all of these should be y equals some coefficient with x. Right here. And specifically, remember in the last two sets ago, we were looking for where x is 1. So on the graph, see on this one, we can just find where x is 1 right here. And then I find the point. What point is that? You guys see those lines right there? It's 1, 4, right? So this y value 4 is the coefficient of x. Bam, nailed it. And it shows on the next one, that's 2, 8. So it's just, we took the x and multiplied it by 4 to get 8. Same with these other ones. This one is -1, -4. -1 times 4 is -4. So that one works as well. Alright, see, this one's different because here's, well, I guess it's not necessarily a problem. Again, we're looking for x is 1, which is this right here. It didn't show us the point though, but we can see that it goes through that grid corner. What is the value of this point? Now we have to be careful because the scale is different. So we know the x is 1, but what's the y value, Radicale? Well, if that's 1, then this is half of that, so it'd be 0.5 or 1/2. So the equation, y equals coefficient of x, which in this case is 1/2. Alright, so we have to identify this point, which right here we see is 12, and then the y value is 72. But what we want to know is what the y value is when x is 1. And it'd be hard to tell what that value is. I mean, that may be 1, but it's hard to tell what that y value is. So we'll have to use some kind of proportion stuff. And again, I always do y's over x's. And I got my equivalent ratios where x is 1. But up in here, we see the y value is 72 when the x value is 12. So to solve with these, I would divide both of these by 12, right? 12 divided by 12 is 1, so 72 divided by 12 is 6. So that means that the point at 1 would be 1/6. And so the equation would be y equals, what's the coefficient of x? 6. It's that y value right there. Alright, now we got to be careful on these graphs because see the scale, we got 1, 2, 3, 4, 5 lines, which on the x-axis gave us 20. So how much is each of the lines worth?
5. 20.
So we divided it by 5.
4.
It's 4, right? So in other words, this line right here would be a 4. Now the y's is going up by 5, 1, 2, 3, 4, 5. So each of these is 1 right there. So what this means is we got this point right here, 25. Now the equation, if we look back, y equals some coefficient times the x, right? But the coefficient is where the x is 1. So if x is 1, what's the corresponding y value? Well, we can use a proportion. So I got my y over the x. Should equal my y over the x is 1. So I divide this by 20 to get 1. And then 5 divided by 20 is 1/4 or 0.25. So the equation is y equals 1/4 x. So let's check on this one. Let's go back. So the equation that we have is y equals 1/4 x. But let's use a point that we see. Let's not use 25. Let's use this other one, which is 24, 8, 32. 32 and 8. Now, if I look at this point, my x is 32, right? So I'm replacing x with 32. Now in my calculator, I can do 1/4 times 32, and then it shows me that y is 8, which is good for this point right here. So it just confirms that this equation is good. So we start with this point up here at the top, and that point right here, the x is 4, so we know it's 4, and the y is 8,000. But here's something that we may see that makes this really not useful, is because see where x is 1? And then we can figure out that point. What is that point right there? It's 1, 2,000, right? Well, that right there gave us the coefficient of x, right? So we got y equals 2,000x. Very good. Now this should confirm, we can use this other point to confirm it. So what's 2,000 times the x is 4? Would be 8,000. So yeah, that seems to work for these. All right, this one, on this graph again, we can see the x is 1, but we don't really know what that value is. We could make some estimations, but still no good. So we need to find some values that we can actually use, like at these. This one is 3, 8. So I'm going to set this up y over x, 8 over 3, should be y over 1. And that would be our new 0.1 something. Alright, so how do we get this? Well, we divide 3 by 3 to get 1. 8 divided by 3 would be 8/3. So it's 1 and 8/3, which is 2.3 repeating. Yeah. No, 2.6 repeating. That's better. Alright, so the equation, I'm just going to use the fraction though. Y equals 8/3 times x.